Right, hello, welcome to What the Hell is Blockchain and How Does It Work? I'll just give you a quick agenda. We're going to have an intro, a little bit about me. We're going to go through the entry-level blockchain path, which is typically Bitcoin. And we'll prime you up on that. But then we're going to have a game of blockchain bingo, which is a game I invented which hopefully helps people understand what Bitcoin mining is and blockchain mining is. I've run about 3 sessions of them before. This will be the 4th time, so hopefully refining it every time. Hopefully you join in the spirit of it. And yeah, and then we'll have some QA at the end. I'd prefer to have it at the end, but obviously if there are burning questions that you have, just shout out during the presentation. So who am I? My name is Perter Thompson. I created a website called KPcoin.xyz. I did this last year. I took 9 months holiday or sabbatical, whatever you call it. And during that time, I just wanted to get underneath Bitcoin and blockchain and really understand it. So I thought the best way of doing that would be create my own cryptocurrency based on the Bitcoin network, because there was nowhere on the internet where you could go and learn easily about Bitcoin. So I don't know whether I succeeded or not, but please go and you can be the judge of it. Go and register on the website. You get free KP coins when you log in, and you can exchange them in a marketplace, which is mostly artwork by my nieces. You can also email me at peter@myaccess.co.uk at any time as well. So can I just have a show of hands? Does anyone own any cryptocurrency at all? Great, we've got one person. Me too. I own 21 milli Bitcoin, which is about 60 quid's worth, so this is not an investment. So what I'm using Bitcoin as an example of blockchain, because it is the first kind of mass use of blockchain. So I'm just using it as an example to get people thinking about it, because this concepts are pretty hard. And so it's easier to use an example as an introduction drug, if you will, to some hardcore stuff.
It's not a one-shot with Bitcoin.
It's not, it isn't, and it is and it isn't, right? Because you can't, I'm going to talk about Bitcoin, and then I'm going to talk about blockchain, how blockchain works on the Bitcoin network. And then we're going to play blockchain bingo. So it's very much the Bitcoin version of blockchain, right? Which will suit people that don't know anything about blockchain. It'll ground them in the most popular blockchain there is out there, and then hopefully then they can go on and see other things. If you understand the basics of blockchain on the Bitcoin network, and you're interested in more funky blockchains that are happening out there, we can have a discussion afterwards, but that's not what this session is about. Okay. Anyone else want? Is that okay for everyone? Losing people now. Okay, so why was Bitcoin created? There was 3 things that I could look at. One was a juicy technical problem, and software engineers love juicy technical problems, as we all know. It was an economic experiment. I think that's undeniable, creating the first decentralized currency. And it was a political statement, given its timing when it came into the world. We're not going to talk about the last 2, unfortunately, because obviously we would just go on forever about those. We're going to talk about the juicy technical problem, which will give you a grounding in how blockchain works. And sorry for the reformatting of this. This is obviously a Windows to Macintosh problem. So the important thing to know about Bitcoin is that it is a collection of already existing technologies or theories. There is nothing new in Bitcoin at all. So public key encryption was invented in the 70s and 80s. The Hashcash proof of work mechanism was proposed as a way of defeating email spam in the early 90s. Hash algorithms were developed by the NSA in America in the 70s and 80s again. The blockchain itself was actually proposed in a theoretical paper as a way of guaranteeing ownership of documents and a truthy ledger. And Merkle trees, which is a way of searching transactions on the blockchain on the Bitcoin network, was developed in 1979 by a chap called Ralph Merkle. So we have missed a slide. Sorry, there is a slide missing here. Oh no, there it is. I don't know why I skipped over that. Right, so what's the juicy technical problem? We want to create a brand new, purely digital currency with no central authority, open to anyone, and you don't have to trust anyone on it. So if you were presented with that as an exam question, that would be pretty intimidating. So how do we solve this? And first of all, why would you start with the problem in the first place? Why would you want to have no central authority? Why would you want to have a decentralized currency? So if we look at an example, a case study from history of a previous attempt at a digital currency, one called e-gold, which ran from 1996 until it was shut down in 2008. E-gold was created by two people. One was an oncologist, one was an attorney. And we know a lot about these people. It's significant that we know a lot about these people, and we don't know much about the person who invented Bitcoin, if anything. Right? It's significant, and I'll say why it's significant in a minute. Essentially, it was a centralized website where people could log their accounts and exchange their credit card details for slivers of gold bars. Or if you were feeling particularly rich, you could buy an entire gold bar. But essentially what you were doing was you were exchanging your US dollars or British pounds, etc., for a token in a gold bar. And you could see the gold bar, you had a picture of the gold bar, there's a serial number of it, and think you could learn to love it. Like, was it Tamagotchi, whatever those kind of things. It was an idea arguably ahead of its time. It accounted for a lot of technical and economic firsts as well. It was the first private money to really be created and to have worldwide acceptance. They had the first mobile wireless payment on a Palm Pilot. I don't know if anyone's old enough to remember what a Palm Pilot was, but they demoed that in 1999, and so that was a long time ago for wireless payments. And then when the dot-com bubble started, or we were right in the middle of it, it experienced exponential growth with lots of merchants beginning to accept e-gold to exchange goods, as well as exchanges exploding everywhere, which would allow you to trade your local currency for e-gold money. Right? So so far so familiar. But then what happened? Well, as soon as it exploded, obviously the user base got very large, and that opened the door for lots of nefarious people to start attacking them. There were some unwanted firsts. It was the first recorded phishing scam, where an email was sent out to all of the people that owned e-gold accounts saying, hey, click on this link and verify your user account and password, please. Of course, it wasn't the real website that they went to. They were going to an attacker's website. Their account details were harvested, and their email accounts were, the e-gold accounts were cleaned out. We weren't ready for it. The world wasn't ready for it, particularly in America, where getting a credit card was as easy as just signing up. This was in the 2000s in particular, where credit was very easy. There was no background checks, all that kind of stuff, so you could just go on and get a credit card, max out that credit card, buy all the e-gold thing, and then launder it into hard cash if you wanted to. So that was a problem. Human nature as well, an anonymous account. So when you logged in, you thought you were anonymous because you didn't have to put your real name in. So you would have good dude 99 perhaps as your user tag. And what happens in that situation is, and it's been shown by Bitcoin as well, is that people tend to get into the big three, which is drugs, terrorism, and child pornography. And that obviously attracted the attention of the authorities. And what did for e-gold in the end was the US Patriot Act. There was a technicality that they got them on, an interpretation of what is actually money. You must have a license in America after the Patriot Act to transmit money in any state that you do business. Initially, e-gold was not considered money, but then in 2006 and 2008, any store of value was decided to be money. So what was interesting about that is Satoshi Nakamoto made a comment in 2009. Satoshi Nakamoto was obviously, for those who don't know, the inventor of Bitcoin. Satoshi Nakamoto is a he, she, or they. We don't know if it's a group of people, if it's a person sitting in their garage in South San Francisco or in Iceland. We have no clue who they are, but they came out with a comment saying, hope it's obvious that centrally controlled nature of the system that doomed them. I think this is the first time we're trying a decentralized, non-trust-based system. So it occurs to me that the idea of the decentralized thing was to get away from the feds, essentially, to distribute responsibility, and certainly the anonymity of Satoshi Nakamoto indicates this as well. So there are problems with decentralization, and these are just a few of them, but there's ones we're going to focus on. How do you register ownership identity if it's open to everybody and it's decentralized? Who is the central clearinghouse for that? How do you prevent double spending? And double spending is a problem where, unlike if you have a £20 note, there is only one of those £20 notes in the world. You can't magically make it into another £20 note. You could give it to someone and then steal it back from them, but that's a different thing. It's still the same £20 note. With a digital currency, what's to stop you from copying and pasting? Right? So how do you get around that problem? And who do you call to complain if there's no central authority? The answer to that one is there's nobody. This is a kind of the concept of being your own bank. There are theories about escrow services where you can find a trusted party that will hold your funds or transactions in escrow until completion. But really, honestly and truly, the idea of this decentralization is you are taking responsibility for your own identity and balance. So to register identity on the Bitcoin network, you basically create what's known as a wallet address. This wallet address has two sides. It has a private and public address. The public address is the address that you give to people if you want to receive money, and the private address allows you to spend the money. It's as simple as that. To create an address, there's a really good website to get your head around this called bitaddress.org. All you do is go onto there, click on the single wallet option, and then waggle your mouse around for about 40 seconds in a random way. And this creates a random entropy that the program recognizes and then creates two keys for you, a private or one wallet address with the two sides, with the private and the public side. Now what's interesting about this is a completely valid Bitcoin address. Anyone that wants to send money to this address, please do. Although all those people taking photos of it have got access to it as well, so be careful. You should never share this side, obviously, that's why it's called secret. But essentially, there is no sign-up process. Right? I haven't entered my name and I haven't put my email address. There's no clash here. There's no one saying, oh, you can't use that address, sorry, that username already, or that wallet address because it's taken. And how does that work? Simply because of probability. The number of possible addresses is somewhere just shy of the number of atoms in the observable universe. So the likelihood of you getting the same address as someone else is very low. And that's essentially what guarantees your identity. It's just statistical probability. The numbers are too huge. But normally you would get a wallet software and you download it to your phone, etc. So I'm going to go through this quickly now because I think blockchain bingo is going to be the fun bit. So anyway, the transaction flow for on the Bitcoin network is that you give someone, so if you want to receive money and maybe they want to exchange with you some goods or services, you give them your public address. They then use their wallet software to create a transaction, and they tag your public address with the outputs of that transaction. They sign that transaction with their private key. Right? They don't expose their private key, they sign it with their private key. Your wallet software verifies that only the owner of that private key could have signed it, and then that means you can then go on and use that transaction in further transactions. So it's basically a double entry ledger account. We're going, if that's not going to break too many people's brains. Essentially you have inputs into your wallet and you have outputs. You have the right to send them out. So, where do those transactions go? The transactions go onto a decentralized ledger, and that ledger is then protected or secured by people called miners or bookkeepers. They are really just glorified bookkeepers. Mining is a term that was popularized by Satoshi, but really they are just bookkeepers. They are just registering and making sure that everything is okay and truthy. So why would you be a miner or a bookkeeper? Well, you help keep the network secure, you keep transactions flowing, and you create currency progressively. But really, what you're after is the block price. which is you get Bitcoin. In the case of Bitcoin Bingo, you'll notice it's lots of tea cakes up the front. So the coin of the realm today will be tea cakes. So that will be your block prize. That's metaphorical. Okay, what's the blockchain workflow? So we've had the transaction workflow. We've had this transaction come in. This person sent it to the address. They've broadcast it to the network, because that's what their wallet software has done. They've tagged it with your public address, and then you've confirmed, your wallet software has confirmed that that person could have sent that data to you. So where does the blockchain come into this? Well, miners are constantly listening for new transactions. They gather those transactions into little local databases on their mining rigs called the unconfirmed transaction pool. They then take those transactions and create what's known as a candidate block. A candidate block is essentially a block in the blockchain. It has rules around it, very, very strict rules as well. And that candidate block can only be of a certain size. So you can't have too many transactions. I think it's 1 megabyte, so it's roughly about 2,000 transactions, depending on the size of the transaction. After they create that candidate block, the miners then try to solve a maths problem, a very hard maths problem, which we'll get into. And whoever wins that maths problem puts that block on the end of a chain. And then that block is absolutely verified forever, essentially. Make sense? So what is the block prize? So the miners win the award. It's called a coin-based transaction. Essentially, it's creating money. So every single transaction on the Bitcoin network, apart from a coin-based transaction, must have an input from a previous transaction. So the only exception is a coin-based transaction, where the miner essentially is allowed to pay themselves Bitcoin. The block prize, the size of it, is baked into the protocol. The initial block prize was 50 Bitcoins. Then every 210,000 blocks that are created on the network, that block prize halves. So it was 50 Bitcoins down to 25, down to 12.5. We're in the 12.5 land. Until we get to 2140, I think it is, they predict the last Bitcoin will be mined. It is capped at 21 million Bitcoin. Now, why that was made was, if you remember the first slide about economic experiment or political decision making, no idea. Satoshi decided that 21 million Bitcoin was enough. What's interesting about that is it's deflationary, whereas most money is inflationary. So there's more money in the system. The more money that gets there, the less value you get for it over time. Whereas Bitcoin should increase in value, and we've kind of seen that in the arbitrage in the prices between fiat currencies and Bitcoin. So anyway, the takeaway there is the coin-based transaction is a special transaction that goes at the top of the winning block that pays the miner the prize. Okay, so we're going to get into the. Go.
If the block prize no longer exists, will there be a drop off of bookkeepers, and will the currency cease to operate?
So I told a little porky there is a way for them also to get tiny amounts of Bitcoin through fees. So when you pay an input into somebody, you will pay a little bit more, and the difference of that output will be what the network decides the fee is for that transaction. So there's a big debate what happens at that, and that's why it's an experiment, right? We will all be off this earth, so we won't have to worry about it necessarily, unless someone has got some secrets. Okay, so we're going to talk about hashing. You cannot talk about cryptocurrency or blockchain or anything like that without hashing, with understanding what hashing is. So we'll go through this. Hopefully it won't break too many people's brains, but it's a little bit mathematical, but not ridiculous. So what is a SHA-256? Sorry, this secure hashing algorithm is one of the hashing algorithms that is used by Bitcoin. There's many others, but this is the main one that they use for finding the block price, so solving that maths problem. So how does it work? All you do is you put a string into your algorithm engine, and it pops out with a number. This may not look like a number because it's got letters in it, but it's a hexadecimal number. Does anyone not know what a hexadecimal number is? Okay, so it's like a base 16 number. So you go from 0 to 9, and then instead of going 10, 11, 12, 13, 14, 15, you go A, B, C, D, E, F. Okay. The reason you do that is for computing reasons, because it's a single character. So it's an easy way to store that rather than getting into 10, 11, 12, which is 2 characters. So it's much more efficient to store it that way. So even though that doesn't look like a number, just think of it as a really, really, really large number. It's a huge number. So you put this in, the string in, and it pops out this number. Now this number is unique insofar as you can't tell by looking at it, without seeing the input, you couldn't tell what the input was. Equally, you can't predict what this will be by putting it in. Right? It's a random thing. But it is deterministic. Once you've done it once, if you do the same string in every time, you'll always get the same answer. Does that make sense? I'll go on to the next one. So if we go to hello world exclamation point, you'll notice that this number is completely different, and that these two together have absolutely no relation to each other. Right? You can't look at that and go, oh, that looks like hello world with an exclamation point next to it. Right? We've got absolutely no relation, unpredictable, and random. So that's powerful, right? Because if you have that concept of randomness and irreversibility, right, you can't break that unless if you knew that, you can break it. But if you don't know that, there's no way you can tell that hello world exclamation mark was the. If you've got one-way hashing like that, then you can start to do some clever things about proof of work and mining the block price. So
can I ask a quick question? So
yeah, sure.
randomness involved in the algorithm itself, it is a deterministic algorithm.
It's deterministic, yes. It's the same output, but unless you know what the output is, but before you put the string in, you won't know what the output is. So we're all finding out it's a mystery. Right? And you can put the entire works of Shakespeare in there, and you'll still get 64 characters out of it. So why is it 64 characters? It's called 256. Each of those characters is 4 bits. 4 times 64 is 256, so that's why it's called that. And the higher you go, you get 512-bit algorithms. The more secure, the harder it is to predict or to break. And if anyone has any questions about quantum computing, we can talk about that afterwards as well. So don't worry, folks. It's not panic stations. The hello world hash number that we found before is here. What we can do also is group that with another string called goodbye world, and then that produces another hash of 64 characters. So it's hashes within hash. Now this one is even harder to predict because you've got to unhash this and then unhash that and then predict what that was to find that. Right? So it becomes more secure the more hashing you go down the chain. And then hello world, again, the hello world exclamation point, you do that and you come out with something completely different. Right, so candidate blocks. I introduced this concept just before about what the miners do, is that they get unconfirmed transactions and they put them all into a candidate block. And a candidate block has 2 sections. It has a header and it has the transactions. Each of those transactions is hashed, and they all hash together to what's known as the TX root hash. Right? And what they do is they hash this entire block and come out with this number as well. Right? It's hashes within hashes, circles within circles. The only variable is this thing called a nonce. Now, I know that on the playgrounds of the UK that means something completely different. I didn't make this up. This is Americans. They probably don't know what they're doing. But this means this is a one-off number. Okay, that's all it is. In computer science, it's a one-off number that you use. So that's the only variable. Everything else is locked. Right? The previous block hash is really important because this hash. So if this was the hash of the previous block, that would go into here as well. The timestamp obviously is important as well. You're giving a timestamp, which will be variable. It's when you stamp it. But it basically has to be within limits. You can't timestamp something from 3 years ago, and it won't be a valid block.
Sorry, I didn't get quite what the
So,
what it is.
So then I'll come to it in a sec. So we're going to, the next few slides describe exactly what that is. Then you have the target, which is the number. So basically, in order to win the prize, you're looking for a number below a certain number. Remember, this is a number. So we're looking for a number that starts with, the current Bitcoin network is actually 18 leading zeros. So you're just looking for a random hash that happens to be below that. That's why it's hard to figure out, because it's random. And then you've got the root hash of all the transactions, but then you've got the nonce. So the nonce so this is essentially what we're trying to do. We're trying to target this number here. We're trying to find, in this case it's 6 leading zeros. This is how out of date the slide is. It's now got, the computing power of the network gets harder and harder, so they get quicker and quicker. And essentially what the Bitcoin network does is adjusts the difficulty automatically. So it should take around about 10 minutes to find this magical hash. Right? It always comes back to 10 minutes. If some mining pool out there is smashing it in 1 minute, the difficulty just increases. They add that. Similarly, if people start leaving the Bitcoin network and the number of miners reduces, that difficulty will come down. Okay, so that's just the basic concept behind that.
Sorry. So every time we do a transaction, just wait 10 minutes.
Yes. That's the payoff, right? So there's always a price to pay, right? It's a centralized system, instant clearing, right? On Bitcoin network, 10 minutes, you have to wait for the confirmation to come through. And if it's a high value transaction, they recommend waiting an hour because you have to get the deeper the block goes, and there's reasons for that. So, okay, this is an example. We've tried a nonce of this, and it's come out with that, with 4 leading zeros. Okay, we're not quite there, so we try this nonce, and it's come out with 5 leading zeros. We're close. And these are random nonces, obviously. And then eventually we get the winner, which is 6 leading zeros. Okay, so we've got 10 minutes to play blockchain bingo. So let's get going. Right, so what is blockchain bingo? Has everyone got a smartphone on them? If they don't, could you just find somebody that has a smartphone? In fact, if you get into teams of 3, it would be really good. So just get to know your neighbours. Just gather together. Right. And so our volunteers, Kat and Olivier, will help you as well. They're going to hand out, Can one of your team go up to, so you'll see some boards around the thing that's got unconfirmed transactions on them. Can you go up and grab 2 transactions and put them on your block? Okay, so we're going to try some random stuff in here. None of this works because the current hash hasn't turned lime green. But if we enter the number 034, it goes lime green. If you see that, please yell out, blockchain bingo. Okay? And then stop. Everyone stops when that happens. That person who finds that winning nonce should call it out. We'll enter it up on the board so we can verify that it's correct. Then they can come up, they get their prize of tea cakes, and we'll put a block on the blockchain. They'll get a new block template and go down. Okay, now, guess what? The first round isn't real. Please do not click the next round starting thing until I ask you to, because otherwise it just gets very chaotic. So, okay, cool. Remember, it's only a demonstration. No, this is not a real competition. I know, juices are flowing already. It's too late. So anyway, 034. If everyone enters 034 into their thing, yeah, good. Congratulations. All right, and now click on Start Next Round. And say yes. And go again. Go. Right, we're for real now. Starting at the start of the round. So 034, start next round, and now you can go. So you're looking for a number with 2 leading zeros, lower than 2 leading zeros, basically. So 2 leading zeros. If you find a number with a hash starting with 2 leading zeros, because we're not cruel, it will go lime green, and then you shout blockchain bingo. Yay, we got one. Yes, you're absolutely right. You unfortunately someone found that. So come up and claim your prize. No, everybody stop, please. Okay, we have a winner. Congratulations. 034, unbelievably 034 works again. I don't know how that happened, but honestly it doesn't work on the next round, I promise you. Claim your prize. If you have you given your template up? Did you not have one? Well, get it off your teammate. Get it off your teammate. Sorry. Yeah. You take that new one back to you again. Okay, so everyone should put 034 in again, so you should have a hash at the bottom of 007 ... 2AC. If you don't have that, you can't play the next round. Does every?
Any 8 digits, so there's only 3.
Say again, sorry?
Since I played any 8-digit combination,
Oh, it's any 8-digit combination. It could be, sorry, any combination of numbers below 8 digits. You don't have to be 8. It can be anything. Sorry. Okay. All right. I think that's enough. I think everyone gets the picture. If you really want a tea cake, come up and grab one. It's fine. But thank you very much. I think we've run out of time. So if you want to grab me in the foyer afterwards for any questions.